Excellent. Thank you, Ron. Thank you, Bert, for a very interesting demo presentation. My name is Anton Slutsky. I'm a technical specialist on the global black belt team over here at Microsoft. The team is basically kind of a pre-sales team focusing on, educating customers as to some of the features that we have here at Azure. That some of them have parity with Amazon, some do not. But definitely we're maybe in the same vein as Bart on AWS end. My focus, as I mentioned in kind of like earlier comments, I'm not as much on the kind of Copilot stack. I'm more on the things that have to do with fine-tuning, machine learning approaches with AWS, with Microsoft. And My hope is to kind of really talk a little bit about in similar vein, I think, to what Bert has mentioned on the AWS and quickly go through kind of what we here think machine learning or kind of like model management lifecycle is. Why AML specifically? I'll obviously do a quick plug of that. What AML how AML differentiates itself from other tools, and then maybe mention again, similar to what Bert has done, some of the kind of management, lifecycle management tools that we have as part of the lifecycle management, and then dive a little bit into what I'm primarily kind of concerned with, what is my role here is to specifically talking about the small language models, as they are kind of a little bit of a poster child right now, especially the multimodal small language models, a poster child for some of the newer things that are kind of like coming up and what people are finding useful on top of the commonly kind of used GPT style models that are what we call large language models, which are being used sometimes hosted at a third party provider. And then if time permitting, which may or may not, I will also touch on some of the Gen AI and prompt flow capabilities of the AML, and then hopefully there'll be questions on it. So it's similar to Amazon is calling it stages, we're calling it rings. I would say it's probably the same thing. We have also three rings of stages of what we consider to be the life cycle. And we have kind of the inner ring, which is the initial experimentation with data, understanding, what sort of use case we're trying to kind of solve, maybe with some of the modern techniques. And kind of usually this aspect is accomplished in a kind of a hands-on notebook style fashion by data scientists, by data engineers that essentially interactively interface with data. And what AML does, it provides tooling to kind of empower those folks that are there for that stage. In the middle ring, we're similar to kind of, like, I think we're all thinking about the same lines. You're starting to think about, productization, what kind of endpoints you're going to spin up, how scalable something might need to be, and so on. Doing some initial training and testing of various various approaches, and then moving into the outer ring, which is where obviously we take it to production. We have scalable clusters with redundancies and auto scaling rules and so on. And so this is kind of how we see the overall flow on the AML side. Essentially, what our platform provides. We're told not to compare apples to SageMaker, but in a sense, a large number of similar kind of capabilities. And what we're trying to do is by using the Azure ML platform, definitely time to value is something that we help to improve. Personalization of ML ops and LLM ops, model management, and so on is something that is again available out of the box in AML. In many ways, much cleaner, I would say, in my opinion, than SageMaker. And then develop we have a compliance platform as well, and the Microsoft has been in the news, and there's a lot of eyes on Microsoft, so we definitely pay a lot of attention to things like compliance and responsible AI, and we have out of the box tooling and filters that allow users to quickly and easily implement responsible AI and compliance rules within various models. Quickly touching on the kind of some visuals around how our platform actually helps deliver time to value and so on. So here you can see we have very advanced capabilities in terms of the training and inference pipelines. These are can be done low code, no code, or a large amount of code solution depending on the team's needs. Here's an example of a pipeline that basically shows two types of pipelines that with one click of a button can be deployed to inference pipeline from training pipeline with all the components kind of available. And these are, again, I won't go into too much detail due to time, but definitely if there's interest of to learn more about how these things work, we can set up actually. And these are some visuals around lifecycle management. Here you can see some of the matrix that we provide right out of the box for trained models, for models that are trained in AML. These are automatically, so we have a very deep integration with MLflow style models. And basically, essentially, if an MLflow model is being trained in AML, there's various kind of measures that come out of the box immediately. And this can be, of course, customized. I will kind of touch really quickly, mostly skip on this one. This basically provides an overview, again, some visuals of our tooling where we provide pre-configured environments that out the box would utilize our hardware, advanced GPU hardware that might be very relevant for things like fine tuning and tuning base models. And we kind of try to simplify it through providing environments that are pre-configured and ready to go out of the box without any overhead on your team. Drives data source, I will again skip to kind of like maybe move but basically the point here is we do have a lot of integration, with a number of integrations with various data assets, including in some cases even Amazon's we can get to through various means. So it's easy to use our infrastructure in combination with other providers if needed. Overall view of the data kind of platform monitoring architecture, where here we're showing that basically we have advanced monitoring APIs that allow for various hooks to be integrated in the model lifecycle. And for example, in this case, we are able to generate events that our platform automatically monitors the inference pipelines and generates events based on things like model drift that can be automatically kick off the process of retraining and updating models as needed. And I will skip on that one just to mention that we also have a advanced catalog of pre-built models. These are essentially obviously all the OpenAI models that are available, as well as a number of models from repositories such as Hugging Face, that we have a team of engineers here at Microsoft that are tasked with monitoring and making sure that these models are compliant in terms of security and so on. So these are exposed as part of AML, can be deployed to endpoints and integrated with various business flows. And now I'm hoping to really kind of jump into something maybe a little different and a little bit more kind of newer things that we're doing. And one of the big kind of entrance into the Gen AI space has been the small language models and the models that are not, for example, OpenAI models, GPT styles, GPT models, and so on. There's a plethora of those. Obviously, some come from places like Meta, Facebook, as well as here at Microsoft, we also have a few. And essentially, what the use case that these models solve are what we call kind of agent architecture, where we have potentially there is a combination of agents that might be required to be put together and orchestrated in order to really solve some particular use case. For example, maybe a customer service request classification model would do a classification, and then some other we purpose built and trained for the classification of some customer service, for example, event, and then subsequent models, including GPT style larger models, can be then used to better serve the use case. And the kind of the advantage of these models, we see a lot of growth, of course, and that's one of the aspects that has been on the mind of engineering teams. and the larger obviously the models you are using, the more expensive they're going to be. And the larger one, well, so I guess number one is many of the larger models are private. So, for example, you cannot take a GPT 4o model to your into your enterprise space and then maybe fine tune or build things on top of that model by owning the weights. The weights of the model and configurations are, of course, owned by OpenAI. And then just in general, the bigger the model that is being used, the more hardware requirements, the more expensive hardware the company might need to provide both at training and at runtime, at inference time. So there's currently it's been kind of like one of the poster childs at the Ignite earlier this year that a combination of more smaller models might actually be more useful for some of the applications. And I guess now I'm kind of really hoping to focus a little bit on what a multimodal SLMs are, or just general language models that are multimodal, what they're good for, what they're used for, and what sort of kind of applications and what sort of thinking may be needed to kind of really use them. And I have some examples here. So, for example, we have a multimodal model that is similar to what Bert has mentioned, can be used to maybe classify some image context or some multimedia content. So in this case, this is an example of a model being used to do a classification whether there's a healthcare event such as a fall collapse, and this is kind of a real use case that we did encounter. And definitely there's a way for you to use multimodal LLMs with very little overhead, just by providing the prompt, please classify this image to do this kind of classification. Can you do it with visual models such as transformer models or some other kind of like object detection models? Yes, you can. With of course, for example, with object detection model, you'd need to do some math in terms of identifying an object of a body and then relation of the body to some other area such as floor, which is error prone and difficult. And in multimodal LLM, it has been trained on the context, so it knows what a fall is. So you can ask it kind of like a very more general, more broad question, as you would, as opposed to kind of a more classical model. And the security application in the middle is essentially, again, to just demo a little bit that we can, the real use case for a language model in context of the multimodality is ability to ask contextual questions that don't require that would be really hard to define in terms of kind of mathematics if you were doing classical approaches such as object detection. So in this case, a question is what the children are doing, what kind of action they're performing, and this could be, of course, an employee doing or some other object there, some other type of person there. This is in case is showing that the model is aware of kind of human semantics, human types of behaviors, and is able to classify, give us a more kind of a very precise answer in terms of the types of actions that are being performed without much additional kind of overhead in terms of training and pipeline engineering to kind of react to some events in the security space. And then on the last example is a little bit whimsical. This is actually my cat, and the cat likes to bring in stuff from the outside. So what I was able to actually test is that not only are the LLMs capable of understanding human behavior, they also can kind of grasp what's happening in terms of overall kind of world context due to kind of the overall world knowledge, what they call training that they receive. So in this case, I'm not interested in cat and mouse being in the same shot. I'm more interested in the complex behavior of a cat, dragging a mouse in, which would be difficult to do with a classical approach. Some pros and cons. Again, why would somebody want to go the LLM route, the SLM route? These models are cheaper, faster in most cases. And here is an example that I actually ran myself, comparing a GPT model, GPT 4o model with multimodality to in this case, Lava, which is a small language model from from Meta. And here you can see that order of magnitude difference in terms of this is X is example and Y is the time it took. So you can see order in terms of seconds. So this is seconds. So you can see the SLM response, definitely order of magnitude faster and will run on cheaper hardware. The flip side of that, of course, is the SLMs are trained on less knowledge. They might not have as much world knowledge as LLMs would, and so they might not be able to answer very complex general questions. And it's also difficult a little bit due to kind of prompt constraints and so on to implement RAG patterns. So these are pros and cons of these models, as with most things there are. I will skip. So basically, this is an example of difference between a multimodal model and kind of implementation with a classical model such as VIT. And here again, as I mentioned, there's a lot of kind of advantages of SLMs as they are more flexible, faster to deploy, time to market, and allow for contextual kind of world knowledge. I'll skip this one and just to show the some of the benchmarks for SLM as compared to larger models, and we can see that there's definitely a variety of results, and some are very applicable to particular tasks, where others are more general, but generally they can be definitely show good results in multiple applications. And so just to give a little bit flavor of what a fine-tuned SLM model is. And it seems that fine-tuning is really kind of the key for SLM success. So SLM out of the box, essentially, you can see here an example. It behaves similarly to a large language model in that it will produce, for example, here I'm asking it for some, what do you see is the prompt, and some individual again fallen. And on the right, you can see the base model response, which is a verbose, lengthy response that makes sense, but it is very maybe difficult if your organization is trying to predicate some business action, some alerting action based on the LLM response. This is slightly difficult to consume. Whereas in this example, I've actually was able to fine tune the. This would be probably this was actually still Lava. Using training data that I will touch on in a second to really constrain the output to a consumable format that is easily usable by automation, essentially, and that can be triggering to some events in a way that a full text response might require a lot of effort to kind of parse through. And this is kind of again the example. The examples that I'm giving are to really kind of give folks an understanding of the what is a fine tuning. There's a lot of kind of buzz around fine tuning, but is not everyone is like very clear what the first value of that is, and then how difficult and what is required to fine tune, what kind of result can be expected. And so the results of the fine tuning essentially are twofold. One is, of course, the kind of the constraining and formatting the output and types of outputs and so on that the a model can produce for you. And the second one is when you fine tune, this is your IP. So this would be something that would remain within your corporate space and would add value to your particular business flows as it would be trained on the data that you possess. So this would be different from a large LLM where the best you can do is prompt flow, and then basically anything that no changes to the model can be proprietary. So in this case, they can be proprietary, and this is an example of how very trivial it is to essentially construct a data set for fine tuning. So in this case, we're seeing a product database training data set that's public, where you have your image, and this is on the right, this is the image, and then kind of the input-output pairs like the prompt and then the response that we're expecting. So here we're asking the model to identify, the type of toy, and then it's giving us the training data is the short, concise output of the types of products. And then in this case, we're doing slightly a different prompt, and again, we have training data around that. So for organizations that have that kind of historical information in their tables, where maybe there have been some product inquiries and so on, it should be very straightforward to really, start utilizing fine-tuned models very, very quickly. In the kind of digital data applications, similar, exactly the same stack can be used to, for example, simplify document handling. And here we're showing some examples that will actually work this way. So if you have, for example, some documents, this is again public data set around some corporate documentation, you can ask the language model to learn based maybe on your internal analyst databases that you've been saving to produce results that simplify overall document processing workflows and decision making around there. And then I'm hoping to do a quick demo. And if I'm this is the one that I'm hoping to really focus on, is that this is a very incubator stage here where myself and a few colleagues are really thinking about what other applications and how else can you, for example, use a visual model. Why a visual modality, multimodality is probably going to be the most important thing going forward in the Gen AI space. Is that here I have examples of my own personal screenshots. So what, like an image is an image, right? So one of those types of images could be the screenshots or essentially the desktops that employees or customers or whatever are looking at. And what we're able to do is we're able to easily capture, of course, the kind of screenshots combined with various kind of operations that are performed by, for example, an employee. So here I'm looking at me using, this is my screenshots using Teams, and I have a demo that I'm hoping to show is that kind of like how I can automate myself out of essentially my own role here at on Teams by essentially fine-tuning a model, a Phi-3 model, using this particular data set where you have kind of an image, the desktop image on the left, and then the training output that we're expecting is a type of action events. So we can get our AI to essentially drive the mouse and keyboard, and maybe ultimately this is of course a simple example, but ultimately complete some business tasks with some additional elbow grease, of course. And I'm quickly going to do that demo, and I think if there's additional time, I will then touch on the prompt flow stuff.
No, this demo would be good, Anton. Spend a couple of minutes on this, and then we'll open up for Q&A and do a final presentation from Wiz.
Okay, so let me kick this off.
Target application not in focus.
So I have to switch to, for example, Teams, and this is
target application in focus.
This is my vacation pictures.
Screen change
and
detected.
Let's see, I am not touching anything. So now it has contacted the fine-tuned model, and in about 20 to 30 seconds, it will click on something or do some action. And I'm also curious what it will do. So give it about 20 seconds. Due to my hardware, I'm running on a internal. We don't have access to very expensive hardware, so unfortunately, I apologize for that. But it will eventually respond. It responded, and see, it's basically typed some text.
Screen change detected.
Let me kill that, so that it doesn't keep doing that. So you can see that it was able to identify that it was looking on the Teams screen. It was able to identify that nothing was typed. And then, of course, this is my personal data that I collected yesterday, so there's not a lot of training. But you can see that it was able to kind of run some, write some input in here. So, of course, with additional testing, additional data, and so on, such a case could be much more complicated and much more involved. And this is basically done through essentially in AML with our AML endpoints that we see here that are very easily consumable and trained using our kind of jobs framework, using some of our accelerators that are very reusable. And basically, you just change the type of data that you're feeding it, and everything else should be essentially there. So it will essentially fine-tune the model for you in our stack, reporting various measures. And that's, yeah, if I have some more content on prompt flow, but if that makes sense as far as Ron, what you're thinking, I'm happy to answer questions if there's any.